Hi, hello everyone. So this is the video dealing with section 1.6, transformations of functions. And in this video, so this section is going to have a couple of other parts, but in order for us to graph functions and using transformations on them, we need to know the basic functions that we are required to graph. So this is going to be where we're going to go over the graphs of common functions. And you see the common functions right here. So we need to know the basic shape of the graph of the common functions, and then we'll apply the different kinds of function transformations. So the ones that we're going to look at are these three. So we have a translation. By the way, the names are not that important, which is we call it a shift up or down, right or left. So this is where we would graph a function in its original format and position, and then we would do a translation, which is a shift up, down, right, or left from its original position. We have a dilation, which is either a stretch or a shrink. So, for example, with the stretch or shrink, it's easier to see when you have a specific type of function. Otherwise, it's kind of hard to see, but we call it a stretch or a shrink. And it's a reflection, which can either be done on the x-axis or the y-axis. So the reflection is whatever the function looks like. Let's say you have a function that looks like this here, and a reflection on the y-axis would be something like this. And a reflection on the x-axis would be something like this. Okay, so reflection on the x, reflection on the y. All right, so three types of transformations. Translation, which is a shift up, down, right, or left. A dilation, which is either a stretch or a shrink of the original graph, or a reflection, which is either on the x-axis or the y-axis. Now, here are the seven functions that we have to know in order to do the graph, the transformations on the graph. Okay? So, and by the way, just keep in mind that even though we're showing you seven functions, usually the constant function or the identity function, we don't need transformations. Okay? So a constant function, and again, and by the way, let me just mention that even though, so this is taken from your textbook, even though the textbook mentions domain and range and where the function is constant or increasing or decreasing, if it's even, odd, we don't need any of this information. It's not necessary for us. Okay, in specific parts of the course, we are going to find the domains of functions. So we don't need it. We don't need it in this section. In this section, we only need to know what the function looks like. So, constant function. A constant function is a function that is going to either be x equals a number, let's say 5, or y equals a number, let's say -3. So this is a constant function. In this case, x equals 5, it's not really a function, but we can call it a function because its graph is a perfect line that it looks like this, but it's parallel to the y-axis. So a real function would be y equals -3. So here you have it, f of x equals a number, and it's going to be a line as you see over here. Here, if it is, let's say a number, it's positive, and down here, for example, let's say y equals -2, parallel to the x-axis. The equation x equals 5, it's not a function because it fails the vertical line test, but it looks like the following. So for example, it would be something like this. Okay, so let's say this is location is 2.2. So this would be x equals 2.2. Not a function because it fails a vertical line test, but it will look like this. So it's a constant line. Okay, constant line. So if you're only dealing with functions, it's going to be y equals a number. And if the number is positive, it would be a line above the x-axis. If it's negative, it would be a line below the x-axis, but parallel to the x-axis. Okay, identity function. The identity function is a line. Okay, so this is the usual format. And you know it from a previous course. Let's say 2x plus 3 or x minus 7. Or if we're just dealing with the basic identity function, no transformations attached, it would just look like this. Y equals x, or as you see here, f of x equals x. So this is the basic function, no transformations attached. If we write f of x equals 2x plus 3, I have a transformation here. Okay, this is one transformation, and this is another, which we'll discuss later. But the basic function would just be f of x equals x, which is what you have right here. So this is a line, just like the constant function, but it's a line that looks like this, crossing the origin at a 45-degree angle. All right? So identity function, no transformations, just f of x equals x, a line just like this, crossing the origin at a 45-degree angle. Next, we have the absolute value function. So the absolute value function is very similar to the identity function. In fact, it's the same function, but for values that are negative, right? So here would be the identity function. But for values that are negative in the negative x, it gets reflected back on the x-axis. So instead of going down, it goes up. So the absolute value function looks like a V, okay? 45-degree angle here on the positive side, and 45-degree angle here on the negative side. That is the absolute value function in its original format, no transformations. All right, next. The next four are probably the most common types other than the linear cases, which is the quadratic function, the square root function, the cubic function, and the cubic root function. All right, so the quadratic function in its original format goes through the origin, and it is f of x equals x squared. And it looks like the absolute value function, but instead of being a V, it's a parabola, okay? As you've seen it in Math 119. It looks like a U shape or a little bit roundy V shape. So quadratic function passing through the origin kind of look like the absolute value function, but it's curved because it's a polynomial function. All right, so that is the quadratic function, f of x equals x squared. The square root function is related to the quadratic, and the relationship is the following. This piece right here gets transformed or shifted or rotated to the right. Okay, only this piece. And going through the origin, you have this half a parabola right here. So this is the f of x equals square root of x function. Now, there's nothing here, and there's nothing here. Okay, this this square root function is not defined anywhere else except in the first quadrant. And you know it because once you take the square root, you can only take the square root of a positive number or zero. Okay, I cannot take the square root of -4. This does not exist. It's not real. It's not a real number. So that's why the function only exists in the first quadrant. All right, so that is the square root function, which is only defined in the first quadrant with the main point at the origin. Now we have the cubic function. The cubic function, it's similar to the quadratic. It goes through the origin. It does have this quadratic function format, which is kind of parabolic, but it's a little steeper, as you can see, going up. But instead of having the negative side going up, it gets, again, just like the absolute value, reflected down. All right, so this is the cubic function. It's not defined. It's not defined here and it's not defined there. Just like the quadratic, it's not defined here and it's not defined there. All right, so this is the cubic, similar to the quadratic, but instead of having both ends going up, on the positive side, it goes up. On the negative side, it goes down. So this is the f of x equals x cubed. And finally, we have the cubic root or cube root function. So this is f of x equals cubic root of x. This is exactly the same as the situation with the quadratic, where there's a rotation and we get this piece. It exactly in the similar way, there's a couple of rotations that we get this piece right here from this leg of the curve being rotated, and this piece right here from the other leg of the curve being rotated twice. Okay, so this is the cubic root. It's not defined here and it's not defined there. So why is this important? Because when we have, I'm going to explain it to you here, but we'll see the transformations on a separate video. So let me just highlight one point before we end the video. We need to know the constant function and the identity function are going to be rarely used on transformations because we normally graph them directly. And we know the graph because we're so used to linear functions and the constant functions. But the absolute, the quadratic, the square root, the cubic, and the cubic root, we have to know their basic positions and shape, because when we graph the transformations, we are first gonna graph the standard function in its original form. So we're going to graph the absolute, or the quadratic, or the square root, or the cubic root in its standard form and shape as it looks, as you see right here, and then we'll apply one transformation at a time. So we need to know and memorize the shape of these 5 functions. The constant and identity are not so important, so that we are able to do the transformations later.